Our perception of the world is entirely reliant on our senses. That's what makes them senses. Taste, touch, hearing, smell, and sight all provide our minds with a distinct and ever-changing experience of the world. Our brain takes in all the signals from our nervous system and filters them into what we experience as quote-unquote reality. I would argue that of all of these, vision is definitely one that has an outsized impact on our perception. Mediums like photography, video, and now the limitless visuals of the internet funnel billions of dollars through entertainment and advertising industries. Understanding the sensory and neural mechanisms behind our visual sense is certainly a worthy cause. One aspect of vision, discovered around 200 years ago by Robert Darwin, Charles Darwin's father, are small fixational eye movements called microsaccades. Regular saccades are the voluntary eye movements that we use to fixate on objects in a scene that we wish to focus on. Once we do this, however, three involuntary and imperceptible processes take over: drift, tremor, and microsaccades. Drift is pretty much what it sounds like, a random, self-avoiding walk that terminates when a microsaccade takes over, correcting for any drift away from or towards a focal point. Tremor is a monocular vibration, meaning independent in both eyes, that is thought to come from noise in the electrical signals controlling the muscles. Of these three, microsaccades have received a significant proportion of attention from researchers. After many interesting and conflicting studies over the years, a definition and understanding of microsaccades has emerged. They are usually defined as a linear saccade of less than 1 to 2 degrees across our field of vision. If you stretch out your arm, 1 degree is about the width of your thumbnail. These saccades are critical to high acuity tasks and the perception that they require. When threading a needle, the rate of microsaccades increases, jumping back and forth between the hole and the thread. Another interesting finding is that the rate of microsaccades decreases when performing a more mentally intensive task that relies on working memory. To better understand how microsaccades influence perception, I have prepared an optical illusion known as the Trochlear Effect. If you focus your eyes on the center of this blurry, low contrast, but still colorful image, you will notice that after a few moments, the colors will begin to fade. Because there is not enough definition or contrast in the scene to trigger a microsaccade, our brains neurally adapt to the fixed image and perceive less of what is actually there. This is similar to how a brain paper overs our nose by combining images from both our left and right eyes. The finding that I found the most interesting is the connection between heartbeat and microsaccades. In a 2016 paper by Sven Ohl, Christian Wohlhut, Reinhold Kriegel, Olga Politas, and Ralph Engbert, found a distinct correlation between microsaccades and heartbeat in participants. This finding not only shows how interconnected all of our bodily functions are, but it also adds another factor to be controlled for in future experiments on microsaccades and visual perception. In the next few scenes, I will try to show, through the audio and some editing of the video, the connection between heartbeat and microsaccades. Because microsaccades are imperceptible to us, I have made some assumptions, exaggerations, and simplifications. This is not science, but I do think it illustrates the link between brain and body in an interesting way. After fixating, our eyes begin to drift and our perception begins to fade. Coupled to a heartbeat, though, a quick microsaccade readjusts and updates, making the image clear again. There's still plenty we don't know about microsaccades and vision. All of the studies are done with a stationary subject, something we rarely experience in the real world. The researchers mostly use screens and cameras to test the vision, both of which introduce biases. We don't know how microsaccades might function with the input from a real-world scene with stationary and moving objects. But there are some very interesting extrapolations that can be made from findings like these. Studies have shown that couples in love or audiences of a live performance synchronize their heartbeats and breathing. This is speculation on my part, but I think an argument could be made that our perception, being linked to heartbeat, might also be synchronized in these situations as well. Our minds and bodies are incredibly complex and interconnected, and I look forward to seeing where new research and perception can help us better understand ourselves and our communication, both intra and interpersonally.